Welcome to Leveraging Network Building Blocks and Industrial Ethernet Architectures. Hi, I'm Andy Manathy, Panduit Business Development Manager. During this webinar, I will be going over a brief discussion of the Industrial Internet of Things and its impact on Industrial Ethernet. This will be followed by reference architectures like Converged Plant-Wide Ethernet. I will then tie together the logical reference architectures with the physical infrastructure leading into a Panduit 5-ins breakdown and the network building blocks. I will close with the manufacturing network maturity model, providing a path for IIoT deployment. Although the term Internet of Things was first expressed back in 1999, IoT has taken off in the last few years. The expansion of IoT has come about with the proliferation of broadband internet, built-in Wi-Fi capabilities, a decrease in connectivity costs, the proliferation of smartphones, and the ever-expanding computer processing power and storage. What is the Internet of Things? The Internet of Things is the networking of machines, vehicles, sensors, actuators, and meters with the ability to both send and receive data. These IoT devices have some local intelligence and can speak to each other. This is what makes IoT different than dumb wired analog or digital sensors. The graphic shows areas where IoT is making a big impact in manufacturing. Of course, the main drivers for manufacturing are increased profitability, lower cost, and greater production output. IoT is key to aggregate the data, make it easily accessible, say in the cloud, and deliver to mobile devices. Essentially, IoT is key to transform the raw data to actionable information and real-time control to unlock the benefits to optimize manufacturing. It provides real-time feedback on the manufacturing process, manages equipment remotely, reacts quicker to quality issues, and responds to condition-based maintenance alerts. Remote capabilities facilitate OEM access for repair and optimization, as well as optimize third-party supply chain management. IoT deployments help management control operational costs, provide insight for R&D to enhance products, and improve response time by maintenance, leading to higher uptime. Back in 2003, smartphones began to connect people to the internet. By 2008, there was as many smartphones or IoT connections as people. This was a turning point for IoT. Beyond 2008, there were more things connected to the internet than people. In the consumer world, think about all the devices that are now connected to the internet, like home security, thermostats, health monitoring, cars, garage door openers, and perhaps even coffee makers. In the industrial world, there is explosive IoT endpoint growth in wireless sensing, industrial automation control systems, gateways, actuators, servo drives, and more. Many project by 2020 there will be 50 billion IoT connections or smart objects. This is more than 6 times the world population. So let's take a look at the breakdown of where IoT is being deployed and the value it brings. The blue circles represent the smallest portion and collectively less than half the value, where each blue circle is 5% or less. The sphere size shows comparative value, where the larger the sphere, the greater the value for the industry. The next 3 yellow-green circles represent about 30% of the value. The greatest estimated share of IoT value is coming from manufacturing at 27%. Most IoT growth is anticipated in manufacturing. Is your network infrastructure ready for this disruptive growth? When comparing the Ethernet OSI model with the IoT model, one of the similarities is the very lowest level. In both cases, the foundation for the OSI physical and the IoT edge is the Ethernet physical network infrastructure. This is the connectivity of the endpoints to the Ethernet network. Without this foundation, Ethernet and IoT deployments are at risk where a poor physical network infrastructure severely hinders communication. Often, this is the most overlooked element when planning IoT deployment. One of the biggest hurdles to deploy IoT is having the industrial Ethernet infrastructure in place. Many manufacturers still have legacy tiered proprietary networks where the industrial automation control system is controlling and directing the traffic. This has served manufacturing very well for many years because it is very reliable and precise deterministic control. Ethernet back in the day was too unpredictable because of its probabilistic nature. However, Ethernet has been advancing with the increased network speeds, network segmentation, and traffic prioritization. Ethernet performance is now on par or better than legacy deterministic network performance. This opens up a lot of new possibilities, especially deploying network from the enterprise down to manufacturing. Convergence, if you will. To leverage IoT legacy proprietary networks, legacy proprietary networks must transition to an Ethernet architecture supplanting the PLC as the network traffic cop. Essentially, the switch becomes the center of the network universe. This is key for IoT capabilities like endpoint sensing for monitoring, mobility for remote assistance, and video for security. Is your architecture more like the traditional three-tier layout or the converged Ethernet industrial network on the right? If it is more like the one on the left, the three-tier, the best practice is to leverage a validated design and architecture. Our alliance with Rockwell Automation and Cisco has unified reference architectures that cover both the logical and physical industrial network. These reference architectures are based on validated industrial Ethernet architectures that can be found in the Converged Plant-Wide Ethernet Design Implementation Guide and other reference architectures. A recent release, Resilient Converged Plant-Wide Ethernet Architecture, is focused on resilient deployments. Various resilient architectures are designed, tested, validated, and documented in this resilient CPwE. These are actual networks tested with the network traffic under load. Going through this rigorous validation process ensures proper deployment for the customer, leveraging and testing a range of different technologies that may be encountered in the field a customer typically uses. What is Converged Plant-Wide Ethernet Architecture, or CPwE? It is simple yet profound architecture that spans many use cases. It provides network services to industrial automation control system devices and equipment. CPwE safely and securely converges the industrial network up to the enterprise network, as well as converges or integrates islands of automation. It's not a single architecture. There are many use cases that have been documented, like network address translation, location-based services, and resiliency, to name a few. It's a framework that has strict traffic segmentation as well as an industrial De-Militarized zone that protects manufacturing. There is a main CPwE design and implementation guide that covers the basics of CPwE, while there are specific use case CPwE architectures that dig deeper. Using a reference architecture like CPwE leads to many benefits for both business and operations. The business gains greater visibility into plant floor to improve decisions. Decisions are more timely and based on factual data. A CPwE architecture reduces costs deploying standard Ethernet throughout the enterprise, eliminating the need to support different proprietary networks. This simplifies network management. Operations benefit by having secure remote access for troubleshooting, reducing the downtime. A CPwE architecture leads to greater network resiliency, minimizing downtime. Having a CPwE architecture will also lead a path for IoT deployment, achieving greater capabilities. This is a modified version of the Purdue model. The Purdue model is the basis for network architectures. It is also adopted in ISA 95. The Purdue levels transcend from the lowest level of sensing, drives, actuators, up to enterprise systems such as ERP. However, this version also includes an industrial demilitarized zone or IDMZ. The function of the IDMZ is to prevent direct communication to manufacturing. Direct communication puts machines and devices at risk with the potential to be disabled by, say, viruses. The IDMZ provides a means to safely and securely pass data up to the enterprise as well as down from the enterprise. There is a transaction manager software that passes the data between the IDMZ. The IDMZ is a key element of CPwE to achieve high security. This is the CPwE reference architecture with network building blocks included. You may recognize that this is based on the campus model of core, distribution, and access. It also shows the typical network topologies like star, ring, and linear with industrial automation control system equipment, including wireless. There are also level 3 site operations compute, storage, and network capabilities running manufacturing systems such as OEE, historian, production control, recipe management, process control, and others. Towards the top is the IDMZ, which securely connects manufacturing to the enterprise. In the next 3 slides, I will be discussing the mapping of logical network topology to the physical deployment based on the redundant star, ring, and linear network topologies. This graphic depicts the building blocks like the industrial distribution frame, IDF, and network zone systems, NZS, along with the cabling and connectivity. It's a physical reference architecture of the logical network and can be used as a basis for a design. This reference architecture is for a redundant star designed with 2 paths of connectivity. The cabling is typically fiber uplinks for reach, bandwidth, and network convergence for recovery, along with copper downlinks that may be hardened for the environment. Since there are redundant paths, this topology has excellent resiliency and bandwidth. This reference architecture is deployed with structured cabling with patch fields. Structured cabling is key for high reliability deployment. It easily accommodates future growth and provides demarcation for testable links when troubleshooting. This is a depiction of a logical to physical mapping of a ring topology. Although it is a ring, the network traffic flows in one direction. So it essentially behaves as a linear topology until there is a disconnect. When a disconnect occurs, the network traffic will flow up to the IDF in 2 paths. This topology has excellent resiliency as it can survive one break in the connection, provided the path is totally independent and not in the same cable. If all links are in the same cable, the cable can be a single point failure because a cut in the cable will sever all paths. Since the ring topology behaves more like a linear topology, the traffic is additive, where the last device traffic is added to the next adjacent device, all the way up to the IDF. Therefore, one has to be careful to not add too much traffic, such as what might occur with a video stream. If you suspect the traffic is too high, a software like Interview can provide the statistics on bandwidth and utilization. This reference architecture is also designed with structured cabling where the uplinks are fiber and the downlinks are copper like the previous example. One interesting advantage of the ring is that it can have longer reach than a redundant star, as each segment can extend out to the maximum length between devices, where the star topology can only extend to the maximum length between the IDF and a single device. This last reference architecture is a linear topology where devices are connected together in a chain fashion. It is deployed with fiber uplinks and copper downlinks as well as structured cabling. It is the lowest cabling deployment cost, but does come with risk as a single break can disrupt production. It has the similar advantage as Ring, where each segment can reach the maximum allowable distance. In this depiction, connectivity is predominantly an M12 sealed copper connector appropriate for a field deployment that requires ingress protection, IP rated. Panduit has simplified physical network deployment by classifying products and network building blocks into groups that are called the 5 Ins. The term in stands for industrial. The first in is in-room. This is typically a control room, telco closet, or part of a data center. This is where you will find computer cabinets and racks, patching, cable management, grounding, as well as our micro data center building block. You may not know that Panduit has over 20-year history of enterprise and data center products and solutions. We are leveraging this segment of our business to bring these capabilities to the manufacturing floor. Our new network performance software Interview is located here as well. The next in is in route. This in includes products and solutions that distribute Ethernet throughout the plant floor. This includes Panduit backbone cabling and connectivity, pathways like WireGrid and J-hooks, as well as our industrial distribution frame IDF and network zone system. By following the previously shown reference architectures, traffic is optimized by keeping local traffic local. The next in is in panel. This in includes products and solutions to incorporate networking in a control panel or enclosure. One of the elements is Panduit's shielding products from cabling, duct, noise shield, and bonding to suppress electrical noise that can disrupt communications. It includes cable management and identification products and solutions for reliability and easy maintainability. This in also includes products and solutions to free up space in a crowded panel to carve out space to deploy Ethernet in an enclosure. Our DIN rail duct combines the duct and DIN rail together to free up 30% more space in a panel. This can be a lifesaver in a brownfield application, avoiding the need to change out the panel for a larger panel, which can be a very high cost and add considerable time to deploy. The in-field area deploys Ethernet to machines and processes out to the field. Often, this is the harshest environment in which cabling and connectivity need to survive. This in includes industrial to extreme harsh cabling and connectivity like M12 connectors, rugged copper cabling, and field terminable RJ45 connectors. Lastly, infrastructure includes products and solutions that strengthen the facility like grounding and bonding, labeling, security, and safety. Panduit has grounding and bonding solutions from the ground up all the way to the device or equipment that is capable of both life safety and high-frequency electrical noise suppression. This grouping simplifies Ethernet and IoT deployments. The 5 Ins make it easy to design and deploy as it is foundational for the reference architecture, making it easy to translate into designs. Our website is designed to facilitate searches for the 5 Ins. The link is in the resource section of the presentation. The network building blocks define a simplified deployment for a micro data center, industrial distribution frame, and network zone system, and where in the architecture they can be found. In the next slides, I will describe the building blocks in detail. A micro data center, or MDC, is a compact deployment of compute, storage, and network, typically in a single cabinet. It is a small form factor data center. In some ways, it could be thought of as an appliance that is specific for manufacturing software. The MDC building block can be delivered pre-configured with cabinet, patch cords, and cable management included, or integrated with active gear ready for deployment and designed for shipment with gear installed. The cabinet design, along with the provided accessories, delivers superior grounding and bonding, easy move adds and changes, and thermal management. This building block takes out the guesswork on what is needed, reducing deployment risk of missing critical pieces that can impact meeting a go-live date as well as long-term reliability. This building block simplifies and speeds deployment, enabling easy, repeatable integrations. The Industrial Distribution Frame IDF is intended for 19-inch RU or rack mount network switch deployments for both distribution and access switches. Typically, these are data center type switches like a Cisco 3850 or 2960 in a protected enclosure to survive manufacturing environments. Although this double-hinged enclosure has been available for many years, there have been many challenges impacting reliability and maintenance. I have seen cases where there is an abundance of backbone cabling and slack preventing the enclosure from closing. The cabling acts as a spring. The power and network cables are pulled out when opening. Patch cords interfering with move adds and changes, and hot enclosures affecting the longevity of the switches. The Panduit IDF building block addresses these challenges. This IDF network building block has a wider stationary section optimized for air conditioning and accommodates stackwise cables. Following Panduit's backbone cabling installation guide, as pictured, ensures that the enclosures will close. A power cord and network cables are secured with slack management features. Fiber cabling is protected, and the use of short, small diameter patch cords makes move adds and changes much easier. All this adds up to a more successful deployment, avoiding the pitfalls that you may have previously encountered. It can deliver 25% faster installation in a single part number. The last network building block is a network zone system. This network building block is designed for DIN mount industrial Ethernet switches, IES. The functioning of these IES switches is mostly the same as rack mount data center switches. However, the industrial Ethernet switch is hardened and is powered by 24-volt DC. This network zone system safely and securely deploys an industrial Ethernet switch. A network zone system is a key element of a zone network topology. This is in contrast to a centralized home run deployment where all cables come from a single origination. A zone topology reduces cabling installation, localizes network traffic, facilitates network resiliency, and accommodates future expansions. Panduit offers the pre-engineered and pre-tested network zone system in 3 integration levels of pre-configured, switch-ready or universal, and integrated in a mild or stainless steel enclosure complete with structured cabling for fiber uplinks and copper downlinks. There is a protective cage around the power system protecting personnel who may not be familiar with working in panels. It is approved for UL 508A and has been tested for shipment. The network zone system reduces time required for planning, designing, procurement, and installation. This table compares the deployment possibilities of the industrial Ethernet switch, starting with a do-it-yourself up to a fully integrated solution with a static switch. The check marks note what comes with each of the possibilities. The circles on the bottom show the time one would spend deploying, where the white portion is what you spend, and the gray portion is covered by factory assembly. So the do-it-yourself to the left spends all their time deploying, where the integrated on the right shows very little time spent by you to deploy. In general, a do-it-yourself approach, although it seems to be low cost, runs the risk of not getting it right and taking shortcuts. The pre-configured option ensures you have the parts you need, but assembly and testing are still required. The switch ready for Allen Bradley deployments and universal for other switches is a proven system ready for a switch. The option integrated with an Allen Bradley Stratix switch is factory tested and ready for deployment, having the least risk for deployment. Heat generated by devices and enclosures or cabinets, along with the ambient air temperature, must be considered when deploying switches in an industrial environment. Panduit thermally validates all network building blocks in our state-of-the-art thermal lab. A range of testing capabilities are performed using thermocouples, as well as infrared cameras in a controlled environment. For the IDF, additional testing was performed with an installed air conditioner. The test data provides guidance with an air conditioner when an air conditioner is necessary for deployment to ensure long switch life to prevent premature failure. Panduit is a leader in thermal testing, where companies like Cisco have Panduit thermally validate their equipment in a full-scale environment all the way up to a data center scenario. You may be wondering how you can deploy network building blocks into your facility. You may be thinking that your implementation is very old and out of date, nowhere capable of IoT deployments. Panduit has laid out a path that can take you from an obsolete proprietary network up to a very robust, highly effective, and long life network fully IIoT capable. Panduit calls this the Manufacturing Network Fabric Maturity Model. Your journey is broken down into 4 levels. The lowest level is called restrictive, where your network is mostly a proprietary control network, perhaps a gateway connected to the enterprise. You may have many islands of automation not connected to a network. Your Ethernet network is not designed and has many unmanaged switches. If this sounds like your situation, then you are considered level 1 restrictive. Perhaps you are beginning to use reference architectures and standards in your manufacturing cells and have deployed an Ethernet network to connect most of your machines, but still struggle to communicate with enterprise systems. You have some documentation on the network, but have no or limited visibility into the network. You feel there are some security holes. On occasion, there are unexplained network outages or slowdowns causing manufacturing downtime. If this sounds like where you are, then you are considered functional, level 2, where using Ethernet but not fully gaining the benefits. Let's say you are deploying networks based on reference architectures like CPwE, where you have insulated the manufacturing network with an IDMZ or firewalls, and have implemented traffic segmentation optimizing traffic flow. You have implemented defense in depth security. You are communicating with the enterprise systems, providing visibility throughout the enterprise. However, you may also feel that you may not have the bandwidth for video or other high output devices because you may be using Cat5e copper cabling or OM1 fiber cabling. You may be lacking robust wireless coverage. You may have desires to connect to a cloud but are not sure how to safely and securely pass data. You have concerns deploying hundreds to thousands of nodes or IIoT devices in manufacturing. If you feel this is where you are, then you are considered effective, level 3 maturity. The last level, level 4, innovative, is a fully functional IIoT ready infrastructure. Being at this level ensures a long, trouble-free network life. You are hyper aware of what is going on in your network and are proactively monitoring the network health and security. You have deployed a wireless mesh technology for IIoT sensors like Zigbee. You have virtualized your manufacturing applications for high availability and resources optimization. You are using the cloud for manufacturing. You have extensive video vision systems and security throughout manufacturing. All this adds up to level 4 maturity, innovative. The innovative level 4 should be the goal in your journey if you are planning an IIoT deployment. To gain more insights on where you are in your manufacturing network maturity, you can download our white paper, A Manufacturing Network Fabric Maturity Model, referenced in the next resource slide. You can have Panduit Professional Services make an assessment and provide guidance for the next steps. Or start with taking a short 6-question survey that will assess the network maturity level you are at. The survey will take less than 5 minutes and is well worth the understanding. In addition, guidance will be provided to you to take it to the next level, achieving the network maturity necessary for IIoT deployment. The following are resources that you can look further into the deployments of IIoT. There is the reference architectures, there is the e-learning courses, and there is the code to take the e-learning courses for free. And you can also take the survey by going to www.panduit.com, map your journey. Thank you. Are you ready to take the next steps to be fully IIoT capable? Map your journey. Go to panduit.com.